All right, if you've ever tried to squeeze every last bit of performance out of a database, I guarantee you've run into this. It's a question that has tripped up so many developers for years. So today, we're going to get to the bottom of what clustered and non-clustered indexes actually mean.
Okay, let's just dive right in. And check this out. This question is pulled straight from Stack Overflow, where it's been viewed nearly 1 million times. So, this is not some obscure little detail. It's a huge fundamental concept that a lot of us struggle with. But by the end of this, you're going to have it nailed down for good.
Now, to really wrap our heads around this, we're not going to start by reading some dense, technical manual. No, instead, we're going to use a fantastic analogy that came right from the developer community. Let's just imagine for a second that your data is a library.
So picture your database table as just the entire collection of books in a library. I mean, without any organization, it's just a giant, messy pile, right? You know the book you want is in there somewhere, but actually finding it would be a total nightmare. In the database world, by the way, we call that disorganized pile a heap.
So what's the first thing you'd do to organize that mess of books? Well, you'd put them on the shelves in a specific order. And that simple idea brings us directly to our first concept, the clustered index. Think of the clustered index as the library's main shelving system. The books themselves, that's your actual data, are physically put onto the shelves according to one specific system, like the Dewey Decimal System. And here is the absolute key idea. The data is the index. The organization is the data. Once you find that spot on the shelf, you've found the actual book. There's no extra step.
And that perfectly illustrates the single most important rule you need to know. A library can only arrange its books in one physical order at a time, right? You can't have them sorted by the Dewey Decimal System and alphabetically by author on the very same shelf. It's impossible. And it's the exact same for your data table. You can only have one clustered index. That's it.
Okay, but what if you know the book's title, but you have no idea what its Dewey Decimal number is? Well, walking up and down the main shelves would be pretty useless. You'd need a totally different way to look it up. And that's exactly where the non-clustered index comes into play. So the non-clustered index is basically the library's old-school card catalog. It's a totally separate, much smaller thing. And this catalog is sorted in a different way, let's say alphabetically by title. Now, here's the crucial part. The card in the catalog doesn't contain the actual book. Of course not. It just holds a pointer, the Dewey Decimal number, that tells you exactly where to go find the book on the main shelf. So when you think about it, a search using one of these non-clustered indexes is always a two-hop process. First, you go look up what you want in the index, the card catalog. Then you take the pointer you found there, you go to the main table, the bookshelf, and then you grab the actual data. That little extra trip is often called a key lookup, and it's a super important detail for performance that we're going to come back to. All right, now this is the part where most explanations just stop. And it's exactly where a huge misconception starts. You know, that common wisdom that says a clustered index physically sorts all the data on the disk? Well, it's time to bust that myth wide open. I mean, we've all heard it, right? A clustered index physically reorders the rows on disk. Even our library analogy makes it seem true. The books are in the physical order. But just think about that for a second. With gigabytes or even terabytes of data on a hard drive, is that really what's happening every time you add a row? And the answer, from an expert on Stack Overflow, is a hard no. That belief is just plain false. I mean, it makes sense when you think about it. A database can't just start shuffling around terabytes of data every single time you insert one new row. That would be unbelievably slow. So what's really going on under the hood? Well, the truth is actually way smarter. The sort order is logical, not physical. The data is stored in these chunks called pages. And those pages are connected together in order, kind of like a linked list. So when a new row needs to be inserted somewhere in the middle, the database doesn't reshuffle everything. No way. It just does something called a page split. It creates a new page, moves some of the data over, and then just updates the pointers in the chain. The physical location on the disk doesn't really matter. All that matters is its place in that logical chain. Okay, so we've busted the myth. We know the secret handshake. Now let's get down to brass tacks. Why does any of this matter? How does this actually affect the choices you make as a developer every single day? This is really where the rubber meets the road. You can see all the trade-offs laid out right here. A clustered index is an absolute monster for range scans, like get me all the sales from last week, because all that data is already sitting next to each other in that logical chain. But the price you pay is slower writes. because of those potential page splits. On the flip side, non-clustered indexes are your flexible card catalogs. Sure, they cost you extra storage space and that extra key lookup step on reads, but you can build as many as you want to speed up all sorts of different queries.
So here's the bottom line. None of this is just academic theory. Really understanding the difference between the bookshelf and the card catalog, and especially knowing the truth behind the physical sorting myth, has a direct, real-world impact on your app's speed. You now get the trade-offs, the raw power of a clustered index for ranges versus its right penalty, and the flexibility of non-clustered indexes versus their cost in space and lookups. You're in on the secret now. So the only question left is, how are you going to index your next table?